Okay, let's go over validation. Um, we're gonna do some sequences from NAMA 2024. This was in Randall, Washington, and we already did a big batch of them, but now there's a second batch. This is gonna be the most sequenced mushroom event in history. Already was with 960 here, 959. Going to be even more here. So let's get into it. I'm going to pick a sequence at random. I'm going to copy this number to the clipboard, and sometimes you have to hit enter for it to show up as a link. I'm going to open the iNaturalist, and then I'm going to go to my project, and I'm going to enter the number here. And after I enter it, I click somewhere off to the side, and that makes it highlight like that. And I'll hit refresh. So let's take a look at this. This is like, I don't know, Anteloma or something. Okay. Now, this was taken actually out of 4A table. John Plischke likes to walk around with a diorama of various like forest debris as a backdrop for the shots. So just be aware of that. Okay. So here's the dashboard page after it loads. You got a couple of things going on here. We've got a link to the iNaturalist as well. You can get there from here. So, same thing. Ignore the M, T, V, and I. None of those you're ever going to use. The only button that really matters is the S button. The B button will take you to a blast search, but I honestly don't like to use that. I like to use everything from the S button. The other thing you'll need is this check mark. We're not going to get there yet. And eventually this button, but let's pop this open. This opens up a pop-up. And then if I click this, it'll automatically open it in a new tab. That's the sequence page. And then same with the blast search. I click it, it automatically opens it into a new tab. And this is where I'm going to start my adventure. So I can see here we've got a little summary. You have two components to this. You've got the NCBI blast. This actually goes to the blast website, and it does a blast search, and it downloads an XML file. So it does this behind the scenes and brings it into MycoMap. And then over here, there's the MycoBlast. This is an instance of Blast. I think it's called Blast Plus, which is living here on mycomap.com. And it uses a custom local database that includes all the sequences from iNaturalist, all the sequences from Mushroom Observer, and then a couple of other databases, an old Unite database, an old Bold database, and Danny Miller's annotated list of sequences. So we'll go over all that. This kind of gives you a breakdown. There's nothing in these boxes, so nothing shows up in these percentage ranges because it's only showing the top, 100 sequences here and top 50, or maybe it's top 50 in both. And a list of names. But I don't really use this that much. I like to actually scroll down here. I don't really look at this either. So here's the blast results. We see a lot of stuff coming up. Anteloma citratum, Anteloma citratum. This one has an iNaturalist number. This one has nothing, just some random stuff. Another one with an iNaturalist number. You can also see location, Oregon, Quebec, Czech Republic, Maine. Seems like this taxon really gets around. First thing I'm going to want to do, hit show more. I want to look for a type specimen, and that would show up here on the right hand side if there was one. and I don't see one, but occasionally you see these. These are imported from Unite, or rather, they exist on Unite as well as NCBI, and it's considered representative sequence for whatever that taxon is. I would give that a little bit more credit than if it was just on NCBI, but I wouldn't trust these all the time. There can be mistakes with Unite often. Often there are mistakes. Some of these are from Fundus, and then one of the things you can do here is you can go to these two down arrows, and you can click View Alignment. And this brings you down your standard pairwise alignment that you get on a blast search. And you can see highlighted is where there's a difference. If I want to see more about this, I can click the number there. This brings you to an imported page. So this is kind of a digested version of what you see on NCBI GenBank with all the same information, but it's just a little formatted differently. Okay, so you've seen that. Now let's go down to the local blast. Ooh, far. Okay, so in the local blast, typically, now not all the time, but typically, the sequence that you are comparing is actually going to be the hit number 1. So anytime someone uploads sequences to MycoMap, they all end up in this pool of stuff in the local blast database. And usually your sequence will show up as the first one. I should note that these are sorted by percent identity and not sorted by the hit number, even though in this case they are all in the correct order. They may not be in the correct order, and that's because the BLAST algorithm uses a synthesis of different components to calculate the hit number. By default, MycoMap will sort by the percent identity. Here you got query coverage, and next to that is subject coverage. Query coverage is how much of your sequence is covered by this sequence. So if your sequence was really, really long, the query coverage would be low if it was longer than the sequence you're comparing against. Subject cover is the opposite. It's how much of your sequence overlaps with, or rather, how much of this sequence is overlapped with your sequence. In this case, you're comparing it against itself, so 100% identity, 100% query coverage. And indeed, most of these are pretty close to 100% query coverage and identity. This is a taxon that has got a lot of sequences. But if we go here into the NCBI, we start to see the identity number a little bit lower. But still mostly great query coverage here is one where the subject coverage is longer. And so let's break that down. If we look at the pairwise alignment, our sequence starts, which is the query, it starts at 1. But the subject sequence, the thing that this is, actually starts at 13, meaning there's 12 DNA letters going here that we can't see. And more than likely, because the subject coverage is only 82%, there's probably a bunch that sticks out on this end too that we're not seeing. So that's what that means. If I had one where the query coverage was low, let's see if this one will give an example of that. Yeah, see in this case, our sequence had 21 nucleotides in that direction. But this one starts here. Hopefully that makes a little bit of sense. One thing I noticed right off the bat is, well, we've got a lot of the same name all over the place, but nothing matches 100%. That's so weird. Everything is 99.85. And what is this percent anyway? What does that mean? it's actually meaningless to me. The percentage, you know, really is relative to the number of nucleotides. Some taxa have ITS sequences that are 450 base pairs, and some have 1200 base pair sequences. So this number is going to mean a different thing depending on how long your sequence is. The average length, somewhere between 650 and 700, it, happens more often than not, but still, what's more important is what the actual differences are, where they are, and that kind of thing. So here we see one difference, and it's the same difference that we looked at earlier. Our sequence is a C, the other sequence has a T. This is actually one of the most common DNA changes that happens just naturally, is a C ends up being paired with a T, paired with it, but a C goes to a T. I could explain the background of that, but it's in the guidebook. Won't go too deep onto that right now. So you could definitely say this is Entomomus atratum, without a shadow of a doubt. It looks like it. How do we know it looks like it? Well, let's look at some. If you go in this column here, you can open up. Actually, if you just click it, I think it opens automatically in a new tab. Here's another one. This is also from NAMA, also on that mossy diorama. Here's one from Point Reyes. I mean, it's pretty recognizable. You always want to take a peek at the macromorphology and make sure it makes sense. Could be like a Galerina in here or something. You need to make sure you look at it. But I'm very, very suspicious by this one base pair difference with all of these sequences. Is that real? Is it an artifact? Is it... Well, let's see what's going on. So you can always get to the sequence page from here. And we know that the top one is ours. We want to confirm that, but the other place you can get to the sequence page is from here. So this takes you to the same page. And it's all going to be... I've opened it now 3 times. Here's the page. I close 2 of them. We're going to click this, and that's going to download the raw data. And you can just dump it somewhere on your computer. And then we're going to click it and open it in UGENE. And so you want to click this option, Join Sequences into Alignment Viewer. Sometimes you get a question that it's not sure what type of file it is. These are always FASTQ files. That's it. Never going to worry about anything else. Just FASTQ. Ignore that. Here it is. Now we got to do a couple of things, and there's some more videos on this. But the first thing we're going to want to do is change the format. And we're going to go in. If you can barely see it, there's a button that says Save Alignment As. We want to do that and save it as Clustal W. And export it in that format. Then we can align it using a tool called NAFT. And we don't need to change anything. And the progress bar is down here. So if you're concerned, it's going to go from 5% to done like super fast. So there's some funkiness going on with this. So what is this? There's one weird insertion of repeats. Oh my goodness. That's really weird. Really weird and unusual. It doesn't show up in your sequence on MycoMap. Let me just explain what you're looking at here before this gets too confusing. So these are all the raw reads generated by nanopore sequencing, and you can see there's a bit of noise in them. They're not the most accurate reads, but when you have a lot of them and the noise is random, you can erase that noise just by consensus. And that's what the computer does automatically to produce this. However, the computer's a little dumb, and it makes some assumptions that I don't like to make. So I generally will recommend going and doing a manual alignment so that you can correct any mistakes that the computer made. Once you get really comfortable, maybe you can skip it in some cases when you're really confident in the data, but until then, I recommend doing it with pretty much everything. The next thing we're going to do is we're going to go to Edit. We are going to remove columns of gaps and set this for 90%. What this is going to do is remove these random columns where there's like one sequence, like here's one where it has an extra AG, it's a mistake, but it made the alignment put this whole column in there for no reason, just to accommodate this. So what doing the, remove columns of gaps is going to do is it's going to, anytime you have one of these where 90% of it or more is white empty space, it's just going to delete it. And you'll see what happens. It's going to take a minute. Usually, it's one of those things where you just have to let it do its thing. If it goes for longer than a couple of minutes, then it might freeze your computer or something. But here we go, we're all done. And what I'm going to do is I'm looking down at this. This is a really bird's eye view of the sequence, and where it's gray, it means everything agrees, and where it's white, it means there's a disagreement. And so I can look where all the disagreements are, and that's referenced here in this little top area. So if I hold my mouse over there, I can see what the disagreement is. 91% of it is T, the rest is combined of these other things, and then some of them are gaps. So that's noise, right? This here, this G, 86% G, there's some 10% A's, so there's a little bit of background noise. None of that's significant. But here I see, a more pronounced dip, and that's going to be significant. You can see what it looks like here. So if I hold my mouse, now it's closer to 50% C and 50% T. It's not exactly, but it's around there. This is shown up as a Y in the consensus sequence. Y means it's both C and T, or it's either C and T. In our case, it's both. And we got to that by making sure that our consensus mode from this little thing is simple extended, and I'm at 75%. I can lower this, and it still stays there, right? If I drop this down to 53%, that's when it changes. Notice it changes from a Y to a C. And that's because 53% C, if I put it at that threshold, it's going to call it a C. Does that make sense? In the other direction, I can keep moving it up, 90, 93. Oop, now suddenly we got things changing. And now, if I bring it all the way up to 100, there's noise in each of these columns. So 75 is a good place to start. 75 may give you too many of these ambiguous codes, but you can always review it. So we see this in the data. What does this mean? Well, let's go back to our blast results here. Remember when we saw there was this difference in all of them here? Well, I'd bet that the reason why there's a difference here is because in our sequence, you actually have both a C and a T. So one way you can look for that is you can copy, I don't know how many that is, 10 or 15 letters, and right after that is the letter you want to look at. And then you can go here into UGENE, and you can go Control F, or just search whatever your search thing is, and paste it, Control V. And now look, it brings you right there. This is exactly next to that letter. So the letter that differed is indeed this one here. And so what we want to do is we want to edit our sequence to reflect this. And there's a couple ways you can do that. If it's just one, then I'll show you that. But let's say you had a bunch of them, and you've reviewed them. That's important. You want to look and you want to make sure it's not noise. You can also have the sequence shifting because of missing nucleotides. There's all kinds of weird stuff that can happen. So you just want to make sure you look at it. It looks like it makes sense. You can see scrolling down, half of them are C, half of them are T. There's no funny business. There's no like gaps over here, shifting something over. That's just exactly how you would expect it to look if half of it was C and half of it was T. So you can right click, and you can right click actually anywhere. It really doesn't matter. And you go to copy paste, and you copy the consensus, not with gaps. No, no, no. You want just the consensus. And that'll have that nucleotide in there. If you want, you can paste it in here. And it doesn't look right there. You have to export it on Ctrl W again, and then it'll show up like this. And here's your consensus. And if we go, oh goodness, I can't find it now. Here, Control F, we just look for Y. Boom, there it is. It's in there. I don't like that method for when there's just one difference. I'm going to go ahead and select all these letters. I'm going to go back to the sequence page. I'm going to hit Edit. You need permissions to edit, so if you don't see the Edit button, you need to ask for the permission. And this is where you can edit all this stuff. Here's where the sequence is. Just do Control F and search for that. And now I know this C actually is supposed to be a Y. So I just change that. And then I'm going to go and I'm going to say reason for edit, annotated polymorphism. That's it. And save. Aha! What happened? It didn't save. Well, it's because there's a glitch in MicroMap and you have to fill this in. And you can put anything you want in there. I'm going to just put the name because I feel like it, Antoloma. But you could put fungi and that'd be fine. Now it's been edited. After it's edited, we want to make sure we run a brand new blast. I'll do 100 because I want to see what else is out there, maybe. I don't know. I like 100. I'm hungry. I need all of them. So now you see this adjusted score of 100. Why? Because it's now seeing that there's a Y, and a Y could mean either a C or a T or both, and so that's probably not a significant difference anymore. So the raw identity, 99.85, and now adjusted is 100. Does the adjusted to 100 always mean that it's a match? Not always. There's some rare situations where things can get very messy, but in this case, we're going to go with it. Now, what name should we give it? Well, I think, to me, it's pretty clear that it's Entoloma citratum, but let's just play devil's advocate. How do we know that this is the real Entoloma citratum? There wasn't a type sequence in the blast results. What we can do, we can go and look at Index Fungorum. Just get an idea of this mushroom. This is the information about it. The basionym, that's the original name where it was described as Agaricus citratus. And this was Fries, was the author. Locality Sweden. This is a neotype. So this was actually designated in 2022. And it was described from, or it was collected in Sweden as the neotype. But it was described in 1818. So this is a European species. At least the type is European. Actually surprised there isn't a sequence for it. I bet there is somewhere hiding. But why do I think I can use this name? Well, we see localities here. All of these seem to be from the United States and Canada. But if we recall, these local databases are going to be heavily weighted on North America, especially United States. You're not going to really see a lot of stuff from Europe until you get to the UNITE. So UNITE are predominantly going to be from Europe. Bold, generally from Europe. So here we got one from Norway. And again, it's that same 100% adjusted match. Here's Danny Miller's annotated sequences. I don't know what this is supposed to mean. Q, UK, question mark. Maybe this is the holotype or something stored at Q. I don't know how to interpret that. One from Russia, question mark. Good question. My point being that we can see this showing up all over the world, and if I reload, maybe the NCBI is already finished. Here it is. So now we can see Quebec, Czech Republic, Sweden. That's where the neotype was from. So I can trust this name. It's probably just a worldwide distributed sequence. That's it. Okay, so let's go and find our iNaturalist observation, which I closed. Yeah, close some things, get rid of some nonsense here. So you used to be able to import to iNat. Now you need to update species. Goodness, it's getting messy. We can't automatically import to iNaturalist right now. So what I'm going to do is just grab the sequence manually and grab the blast search. So I got the blast search, make sure it's the new one. Then I'm going to go over here, I'm going to copy the sequence to the clipboard. So now I have them both on my clipboard. And I'm going to go in here and I'm going to go to DNA barcode ITS and open up my clipboard, paste that. And then I'm going to go to MycoMap blast results, open up my clipboard and paste that in there. It's really helpful to have a clipboard storage device thing. And then I'm going to put sequencing technology. I'm going to set to nanopore. I'm going to also then add it to project dnama. And then I'm going to identify it. iNaturalist was pretty close there. So why do I think it's that? Not sure if this is the best way of explaining it. It's late. We'll go with it. Matches except for one ambiguous position to a worldwide consensus of sequences using this name. And if you want, you can always provide some context. So I wonder, Danny referred to some sequence, and then there was also some others from Sweden. So here's some from Uppsala. I wonder if any of these are just randomly the holotype. I don't know who these people are. Oh, they have their own fungal diversity survey in Sweden? No way. I have to talk to them. There can't be two. Just kidding. There should be infinite. Yeah, it seems like it's all the same group of people. Yeah, it's all the same people. Well, I'll just use one of them as a example. And actually, instead of linking to this page, I'm just gonna look for GenBank in Google search. And here I'm just gonna search that number, which was, whatever number up there. So here's just one of the random ones from Uppsala. And I'll add that. Okay, that's like way more evidence than I really need for something that this is a very common taxon, well understood worldwide, pretty much. So, okay, so I've done this part. I added it to the projects and all that. So let's just finish up. So let's refresh the external data. Hopefully that will fix this disagreement it's having here. It's taken a little longer than I'd like. While it's doing that, let me go into my sheet. So let me fix something here. Okay, working. Me. Sequence status is good. There's a lot of other options. Those are in the guidebook. It explains it. Validated. Entoloma, cetera. If you don't know how to spell it, you can always copy and paste. New name? No. There is a Danny Miller reference. This is specific to this NAMA project. We are highlighting anything that doesn't have a reference from Danny Miller. We saw references. Novelty, nothing novel, nothing notable. There's a whole list of things to choose from. I added the sequence to iNaturalist, and I'm almost complete. There's one thing left to do, and that is click to verify. And now it's complete. And now I can mark it as complete. And I can go in here and copy my notes and paste them here. And paste the values only so it doesn't look weird. Okay. I believe that's it. Hopefully I didn't forget anything.